Hi everybody. Once again, sorry for the first video not presenting. Hopefully the second video will present the worksheet. I did describe it, so if that made sense to you, awesome. But this is just about the worksheet, so if you already got it done, you don't have to watch this. Awesome job. Okay, so I am going to try this one again. All right, so hopefully you can see my worksheet screen. This is what you guys are all seeing. All right, and this was your homework for today. I described how to do it, but I will do it again just so you guys can see what I am doing while I'm going through this. All right, so to access it, you plug in this website, okay, and you type in that, and it pulls up this, okay. All right, and to look back, it says drag your mouse to the Simulations tab and click Chemistry. Simulation, scroll down, click on Chemistry, okay. The next step says scroll down and click on Gas Properties Simulation. Okay, scroll down, alphabetical order, so Gas Properties Simulation. All right, and the final step says click on the play button to run the program and select Ideal. All right, so click on the play button right there and let us select Ideal. Okay, now we're good to go. We're ready to get started. Okay. All right, so the first step, define pressure, okay? Just define what you think pressure is, okay? All right, second step is make a prediction as what you think will happen to a certain gas in these conditions, okay? A prediction, this is our hypothesis. It's kind of just like a guess. We don't know. Some of you actually might know, all right? But you're just making a prediction. So if I hold my constant temperature, I'm gonna do the first A right here. If I hold a constant temperature, and I increase the pressure. So I'm increasing the pressure. What's going to happen to the volume? I'm going to guess my volume is going to decrease. So I'm going to bold that one. Oh, okay. So I'm going to bold that. Oh, there we are. Okay. If I, constant temperature again, if I increase the volume, what's going to happen to my pressure? If I increase my volume, I think my pressure is going to decrease as well. This is my guess. But I want you to guess on these. Let's say, I guess, increase, I guess decrease there, increase, and increase. I don't know. They're guesses, okay? And then I'm going to scroll down, and this is where you simulate, all right? So I'm going to walk through a couple of these examples real quick. So at a constant temperature, okay? Constant temperature. So I'm going to go back to my simulation here. Holding constant. All right, what am I going to hold constant here? Well, I can hold my volume constant. But if you add particles, let's add some heavy particles. Okay. If you add some heavy particles, all right, my computer about died there. Okay. Add particles. Now I'm going to hold temperature constant because that's what the worksheet says. Okay. Temperature constant. Okay. The next step says, what if I increase the pressure? That's what the X means. X, increase. Increase in pressure. Well, how you increase in pressure is you press the pump. You pump it up and down. Poo, 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 poo. I'm increasing the pressure. And as you can see my valve up here, my pressure's at 30, 35, 40, 50, 60, 70. I'm increasing the pressure like crazy. Okay. What's happening to my volume as what's happened between the space of the balls? Well, it's getting smaller. Okay. So my volume's actually getting smaller. So I'm going to put an X on the small side. Okay. That's one way to do it. All right, next one, constant temperature again. However, this time we're going to increase the volume. All right, so I'm going to restart, add some particles. All right, so my pressure right now is about 5.56. It fluctuates, right? However, what happens if I increase the volume? And how I do that is I pull this handle here. Ooh, what happened? It went down, right? So what you are going to do is you are going to put it down pressure, okay? That's how you solve that. All right, so that's how you increase, decrease pressure. That's how you solve for volume. The last one is temperature. So shows right here, I have to have a constant pressure, constant P. Okay, so I'm going to restart, add some particles. I'm going to keep my pressure. Okay, keep my pressure equivalent. However, what happens if I add heat? What happens to my volume? Oh, pressure cannot be held. The volume is too large. All right, so when you add, this is how you add heat or take away heat. You can cool things down. Okay, so those are just ways how you can simulate it. Okay, and then you get to the questions. All right, hopefully you will be able to answer most of these questions. The one thing I do want to describe is direct versus inverse. Direct means if one's going up, the other's going up. All right, inverse, as one's going down, one's going up. Okay, so if we look at when constant temperature, what's the relationship between pressure and volume? Well, pressure goes up, volume goes down. All right, pressure and volume, well, one goes up, one goes down. That means this answer right here is inverse. Okay. Hopefully that helped out seeing the page a little bit. If you guys have any more questions, please let me know. Thank you very much.